Hello everyone. First of all, let me introduce myself. My name is Samuel Benedete Hoffman. I'm a mechanical engineer graduated from Universidade de Caxias do Sul. In this sequence, I'm going to present the article Analysis of Vehicle Powered by Supercharged versus Aspirated Otto Cycle Internal Combustion Engine. Here is our agenda for this presentation and how we're going to follow along. We're going to have a brief introduction. I'm going to describe the experimental procedures, go over the results, and finally the conclusion. Because of demand of internal combustion engines with lower level of emissions, there was a search for small models, however, with great power output. One way to achieve said product is by using a turbocharger which improves the engine volumetric efficiency. Georgi says that the reduction in engine displacement and the use of a supercharging system to maintain torque and power is called downsizing. Basically, the turbocharger consists of a compressor and a turbine installed on the same axis. The turbine uses the energy from the exhausting gases to operate the compressor. The compressor supplies a greater volume of air into the cylinders. In Brazil, the emission standards for the internal combustion engine are established by CONAMA. This standard specifies vehicle inspection procedures, emissions limits, and vehicle pollution control plans. An important factor for the correct functioning of internal combustion engine is the lambda factor, which relates the actual mixture to the stoichiometric mixture of air-fuel as shown in equation 1. The lambda for maximum powers occurs between 0.85 and 0.9. The stoichiometric air-fuel mixture where lambda is equal 1 is normally used to cruising speed. Let's move on the experimental procedures. A Volkswagen Golf 1994 passenger vehicle was used, equipped with a spark ignition engine, electronic injection, and a single-point injection in each cylinder. The main engine characteristics are presented in Table 1. These main characteristics were used to configure the injection maps, ignition maps for the electronic measurement module. Well, how the work was conducted. The aspirated engine was initially removed from the vehicle and the torque and power measurements were taken. After that, the engine was reinstalled in the vehicle and the torque and power measurements were carried out again according to the standard NBR ISO 1585 from 1996. Emission rates were also measured. During the test with the aspirated engine, only podium gasoline was used. The turbocharger was selected and installed as well the necessary components for its correct operation. After that, torque and emission tests were made, however, with 4 types of fuels being used. Podium gas, E50 with a mixture of 50% hydrous ethanol and 50% podium gasoline, E75 with a mixture of 75% of hydrous ethanol and 50% podium gasoline, E100 with 100% hydrous ethanol. The emission levels of hydrocarbons, carbon monoxide, carbon dioxide were also collected. These measurements were done following the CONAMA standard. Table 3 shows the volumetric efficiency estimated in 85%, engine volume of 2 liters, atmospheric pressure of 100 kPa, and room temperature of 25 degrees, with the compressor discharge gauge pressure at 80 kPa, as shown in Table 4, obtain the mass airflow calculated according to the column in red and with the pressure relation found at 1.8. Based on the map defined by the manufacturer, the theoretical efficiency of the compressor was defined, having them on efficiency between 66% and 74%. With the mass airflow and the ethanol fuel-air ratio around 9, a mass fuel flow of 0.0214 kg per second was found. With this, a fuel pump with a flow rate of 0.0479 kg per second at 3.5 bar was selected and a 0.0455 kg per second at 4.2 bar according to the manufacturer. It is important to mention that as the pressure increases in the intake manifold, the pressure in the fuel line must increase proportionally. The injectors selected were from the Bosch brand with a flow rate of 0.0082 kg per second for each injector, with a total of 4 being used, 1 for each cylinder. After the adjustment of the lambda factor close to 0.85 was performed for the vehicle at fuel load in the inertial roller dynamometer as shown in Figure 3 in the red line. The green line shows the pressure in the intake manifold with gauge pressure limited to 80 kPa. And the blue line shows the engine RPM. After the adjustments made, the main fuel injection map is shown. The fuel map reconfigured for lambda 0.85. The ignition map that utilized was the one generated by the module software according to the characteristics of the engine. Comparing the results from the aspirated engine in the bench with the results from the inertial roller dynamometer is possible to verify a transmission loss of 16.9% at the peak power. Comparing the torque at 5000 rpm, it is possible to verify that supercharged vehicle has its highest torque value of 218.6 Nm. At the same point, aspirated vehicle already has a loss of efficiency having 124.8 Nm. However, it is also possible to verify that the aspirated vehicle has greater torque up to 2800 rpm due to the fact that the energy of exhaust gases is not sufficient to start the compressor. The power, in a similar way as the torque, has increased considerably with any fuel, having 66.4 kilowatts in aspirated form and 114.5 kilowatts for the supercharged. As shown in Table 7, with the aspirated engine podium gas type, the highest torque value was 139 Nm. Using the same fuel and a supercharged engine, the reached torque was 197.9 Nm. The highest value was 218.6 Nm supercharged engine E100 gas type. The power also increased in the supercharged form with all fuel mixtures. An important factor to verify the performance of a vehicle is the mass power, being that in the aspirated form the vehicle had a ratio of 15.96 kilograms for each kilowatt, and in the best measure being with E100 turbocharged with a ratio of 9.26 kg for each kilowatt. According to economic standard, vehicles produced from 1992 to 1996, the generated carbon monoxide limit is 3%, and 700 ppm for hydrocarbons. As shown in Table 8, in all performed tests the vehicle was approved according to the standard. In comparison with the other fuels, the E100 gas type had the best results for the supercharged engine. At 2,500 rpm, the vehicle was also approved according to the standard. However, the best turbocharged result was reached with the E75. As previously demonstrated, the vehicle has increased power and still complies with the current emission standards. The best results were found with the E100, with a considerable increase in power and torque in accordance with the current regulation. Thank you all for your attention. If you have further questions, please let me know.